first of 3 POs right in a row, 62, 63, 64. And today we'll be talking about inscribed angles and their relationships within circles. So we've talked about central angles, right? A central angle, it is equal to, my touch going to work? Oh, it does. A central angle is equal to the arc that it creates. An inscribed angle is an angle with its vertex on the circle. Okay? An angle with its vertex on the circle. An inscribed angle is an angle with its vertex on the circle. So we have a central angle, which we talked about in PO60. That looks like this, right, with its vertex at the center. And the relationship between the angle and the arc it creates, they are congruent. Okay? Yep.
Can you print me off?
Not right now.
No, like.
Oh, a whole new.
Yeah.
Yes, I can do that. Okay. But an inscribed angle, it says its vertex is on the circle. It's going to look like this. Isn't it? It is. Okay. An inscribed angle has its vertex on the circle. In the relationship, we'll call this A, B, and we'll call this point C. The relationship is angle ACB is half the measure of arc AB. Okay? Angle ACB is half the measure of arc AB. So, whereas a central angle, there's a direct relationship that the angle measured and the arc are congruent. With an inscribed angle, the measure of the angle is half the measure of the arc that it creates. So, for example, if this angle measure is 75 degrees, what would the measure of arc AB be?
75.
No, for a central angle, that'd be correct. The measure of the angle is half the measure of the arc.
So let me get another shot.
Go for it.
I'd say 1 force plus 10, 150.
150 degrees. Okay? Another way to say that is the arc measure is double the measure of the inscribed angle. Okay? But this would be the formula here.
But which one is the same as?
Okay? Central angle, where the vertex is at the center of the circle, that's the congruency relationship. For an inscribed angle, where it has the point on the circle, the measure of that angle is half the measure of the arc that it creates. Okay? Good so far? Okay. Theorem 10.8 has to do with if you have more than one inscribed angle in a circle. Let's say that we had something like this. Here's our circle. Okay. We have one inscribed angle that goes like this. And another inscribed angle, I'll do it in red, that goes like that. Okay? Now, if you'll notice here, both of these inscribed angles create the same arc. Right? Both inscribed angles create arc AB. What do you suppose we can say about the inscribed angles themselves? They are the same. Okay?
Wait, what's the same about that?
Because our two inscribed angles, the one in green and the one in red, they create the same arc, right? They're starting at different points on the circle, but their rays create the same arc, arc AB. Because of that, we know the two angles are congruent.
Yeah, I got it.
Okay? They do make triangles when they intersect each other, but they don't make a triangle with a circle.
The angles are congruent?
Yes. The inscribed angles are congruent, yeah. So if we knew that arc AB was 60, okay, what would the measure of each of the inscribed angles be? 30, right? Because the measure of the angle is half the measure of the arc, or flip that around, the arc measure is going to be double the measure of the inscribed angle.
Oh.
Oh, I get it.
Right?
Because it's double, right?
Yep.
I thought it was just you were adding them together at first.
Well, that's what doubling is.
No,
Adding
well, you're
something
adding
to itself.
30 plus 30.
Well, they're each 30 here because they
So
create the
wouldn't it
same
be
arc.
60-60?
No, because they're different angles.
Why is it 60?
Yeah, I know, but wouldn't it
The
be
arc measure is
60?
60 because it's double the measure of the inscribed angle. This arc is created by this angle here in green there. So if I know this is 60, I know this green angle is 30. But I also know the red angle is 30 because this red angle creates the same arc.
Well, it's I thought this said 130. My bad.
No, oh, no, that's a congruency curve. Sorry. Okay.
I was about to say.
Inscribed polygons, you worked with these before when we do the shaded area. Question, you often have like a circle inscribed with a square or something like that. Yeah.
So what's the theorem? Like, what are we writing?
Oh, sorry. The theorem is that two inscribed angles that create the same arc are congruent. Two inscribed angles that create the same arc are congruent. And there's the example there. Other questions folks might have? Two inscribed angles that create the same arc are congruent. My arc and R look awfully similar, but this is there we go. Much better. Much better. Inscribed polygons. Who knows what an inscribed polygon is? If you think about what an inscribed angle is, what an angle is, and then the fact that this is an inscribed type of angle, you think what a polygon is, then think of an inscribed polygon. What do you think, Anthony?
Polygon inside a shape or a circle.
A polygon inside of a circle. Okay, specifically circles. See, that's what we're kind of talking about. But what? Tell me a little bit more. Because you're right. But like, would this be an inscribed polygon?
No. That's
No.
to touch the
Edges have to touch the edges.
Right. So an inscribed polygon is a polygon with each vertice or each vertex, singular, on the circle. Okay? A polygon with each vertex on the circle. And so we're actually going to do theorem 1010 first, just so we can draw an inscribed polygon. Here's our circle. Here's our inscribed. Quadrilateral. Okay. Notice how each point of the figure, each vertex of the polygon is on the circle. Is it a kite? That's actually a pretty good looking kite, isn't it?
That's how you
That's
should
what you
draw
draw.
kites
Yeah, I think I cracked the code.
You cracked the code!
My teachers don't ever get excited about stuff. They'll use mock. Okay. But what theorem 1010 says is that for an inscribed quadrilateral, I spelled it wrong. Quadrilateral. The opposite angles are supplementary. For an inscribed quadrilateral, the opposite angles are supplementary, which is different from what we talked about in our quadrilateral unit because this is not a parallelogram, right? But in order for it to be inscribed in a circle, it's not going to be a parallelogram, unless it's a square or a rectangle. But the opposite angles are supplementary.
So which are the opposite?
Opposite angles. So if we have this angle here, the angle opposite to it would be this one here. Okay?
So there.
Ah.
So if we knew that this angle was
So there.
105, then the other angle in red would have to be
No.
75.
Wait, why is that?
Because supplementary means they add the 180.
Oh.
Okay?
Oh, but what if it was we knew the one to the right of 105?
Then the angles in blue, which are also opposite angles there, right? If we knew that this one was 60, it would make the other angle in blue 120. Okay? And of course, just like any other four-sided shape, all four angles added together have to equal 360, okay? Which they do, right? So that's what's special about a quadrilateral. What's special about a triangle inscribed in a circle? We'll say the diameter no, I'm going to change that. Sorry. If an inscribed triangle includes the diameter, then the triangle is a right triangle. Okay? If an inscribed triangle includes the diameter, then the triangle is a right triangle. And we'll draw a little picture to correspond with it shortly. But if an inscribed triangle includes the diameter,
How do you spell angle?
huh? Angle? A-N-G-L-E.
There's some days where you just
I would mock, but I spelled quadrilateral Q-U-A-T at first before I changed it to it.
I'm trying to spell triangle.
How come you'll spell
So here's our circle, okay? You can have a number of different inscribed triangles, right? Like we can have an inscribed triangle that looks like this. Okay, that's an inscribed triangle there because it's got its points on the circle. However, if a side of the triangle is the diameter, okay, then no matter how else it's positioned, it has to be a right triangle. Okay? If a side of an inscribed triangle is the diameter of the circle, no matter how the other two sides go, it has to be a right triangle. And not only that, but because the diameter is the longest possible chord you can have in a circle, because it passes through the center, what do we know about the diameter? It's the hypotenuse of said right triangle. Okay? So you can have a number of different triangles inscribed in a circle, but if one of those sides of the triangle is the diameter, you know the triangle is right. Which of course opens the door for
The Pythagorean theorem.
Pythagorean theorem! And sine, cosine, tangent, 45, 30, 60, 90. All those things we know and we love. Okay? Questions on the notes? Questions on the notes? Okay. All right. So
there's another PO after this.
there's two more after this.
Oh.
Oh, just wait till you get to secants and tangent. That's a goodie.
What?
Yeah. Okay. So anyway, here are 7 things. Oops, 7 things I asked you to solve for.
Let's be homework.
So just take a look. This first one just has to do with a basic inscribed angle. The second figure has to do with those 2 inscribed angles that create the same arc. And the third one has to do with an inscribed polygon. Raise your hand if you can tell me what is the measure of arc QT.
50.
It's 100.
David, it's one thing to be loud, it's another thing to be loud and wrong. So please raise your hand.
How does that make sense though?
Who can tell me the measure of arc QT?
What does RS say?
Yeah, I guess.
That says 48.
It's like
48, sorry. Didn't copy that well. Okay. But who can raise their hand and tell me what arc QT is? We'll start there. Arc QT. Joey,
100.
how do you know it's 100, Joey?
Yeah.
10 minus 7. Of the theorem. Where'd it go? 10.7.
Which says what?
It says that up there, the angle of the one, it's like the arc is double the top.
Yeah. So when you have an inscribed angle, so Damien, notice here now, this vertex is on the circle, right? We have a central angle, which has the vertex in the center.
The P's in the middle.
Point P just marks the center of the circle. The vertex of the
So
angle
it doesn't
is
matter.
point R.
Oh,
Okay.
I got it.
The vertex of the angle is point R.
So that's-
And what theorem 10.7 states is that arc length that this angle creates, angle QRT, is double the measure of the angle. So if the measure of the angle is 50, we double that, and arc QT is going to be 100 degrees. Okay? That difference between the central angle and the inscribed angle. The next question asks for RTS, which of course means that we're going the long way around here. Angle RTS.
We have
Oh, it's
RTS twice.
Well, because
Is
actually,
that
it's the next one.
24?
Next, the second RTS is for the next one.
Is that
Yes,
24?
It would be 24. Okay. In this case, you're given the arc measure. The arc measure is 48. Angle RTS, which goes from point R through point T, and then over to S, is half that measure. So that would be 24 degrees. Okay. This first diagram is just applying that relationship of an inscribed angle to an arc measure. The angle is half the measure of the arc, or flip it around, the arc measure is double what the angle is. Okay? Folks, the next one, RTS again, but a different RTS, different diagram here. Who can raise their hand and tell me what the measure of RTS is and
35.
explain why?
Jack.
Catherine.
31.
And how'd you get that?
Your case.
Well, this 31 refers to RUS. I'm looking for RTS.
This was 48.
Anthony.
Because they create the same arc, so they're
Very good. Okay? Because these two angles create the same arc, both of these angles create arc RS here. Okay? They're congruent angles. So if one of them is 31, the other one has to be 31 degrees as well. Okay? And then, what is the measure of that arc?
I don't know.
62. So then RUS
I couldn't tell you.
We're looking for RUS, which is actually all the way around.
I said 31.
Oh, yeah.
Hey, I'm saying quiet
I know
either
what it
to
is.
class or to someone or to Damien after every sentence that I speak. Just please, if you want to participate, I love it, raise your hand. But the key there is raising your hand. Okay? Raise your hand.
I think about it.
Because it's 3 letters, RUNS, we are going the long way around here. Okay? It's a major arc. What's that going to be, Sophie?
298.
And how'd you get that?
67
So we know that arc SR is 62 because it's double of that inscribed angle, right? The inscribed angle is 31, so the arc measure will be 62. But we're not looking for arc SR here. We're looking for all the rest of the circle, okay? Which means if we know the whole circle is 360, we can subtract that 62, and Sophie got a measure of 298 degrees. Okay?
I did 118 because I thought it was 180, but I realized that
Yeah.
I was wrong when Sophie told me the right answer.
Last one. Dealing with an inscribed quadrilateral, we are given values for each of the angles. How can we figure out what those angles are in actuality, though? How can we figure out what the actual measure? Yeah, Lisa.
So I did 4A equals 180, and then I solved that. So A would equal 45, and since that's, then you multiply that by 2, there's 90.
I know. He's trying to be Darth Vader.
Okay, so Vince, quiet please. Turn around. Jack, quiet please. Turn around. So we have those two. Claire, quiet please. Turn around. Like whoever's talking, stop. We have those two angles, and we know they're supplementary because they're opposite. And with an inscribed quadrilateral, the opposite angles are supplementary. Okay. So the equation that Lisa set up is 4a equals 180. If one angle is 2a, and the angle opposite is also 2a, together 4a's supplementary, you know that they're 180 degrees. Okay. And so she got a equals 45. Which makes this angle measure 90, and this angle measure 90 as well. Because if A is 45, two of them will be 90. Four of them make 180, which is what 90 and 90 is. Okay?
Yeah.
The other two are 90? No.
The other two, which are labeled 4B and 2B, we can make a similar equation. We have a total of 6 B's there. And because we know that they are supplementary, we know that those 6 B's have to combine to make 180. Which means that 1 B is how much? 30. So if 1 B is 30, then angle M here, its actual measure is 60, two of them, 2 times 30. And angle K there, 4B, would be 120. Okay? And you can do a quick check on this. I'm confident that we're right, A, because I've done this before, but more importantly, these 4 angles add me 360, right? Which is what really matters here. So now we can look for these various arcs. Our first one is arc KJM, which means we're going from point K through point J and over to M. Well, how do we know it's half the circle?
That's a right triangle.
Okay. What arc or what angle creates arc KJM? J doesn't create KJM. L creates KJM, right? Angle L here, its rays go down to point K and point M. It creates arc KJM.
Oh my gosh, it's a semicircle.
And it is a semicircle. How do you know that, Ellen?
Because it's 180.
And how do you know it's 180?
Because 90 times 2 is 180.
Because the angle measures 90, so we double that for the arc measure, and it is, whoops, not 90, it is 180 degrees. Okay? Sometimes it can be difficult to identify what the arc measures are. Anthony, would you like to stay or would you like to go?
I'll stay.
And stop showing your knees. And pay attention to what's up here. Okay?
Wait,
Okay. Jack, quiet, turn around. That number was you. Okay? So, Catherine, KJM, we're looking for that arc. Means we're going from point K, right, through point J and up to M. Okay? So now we have to look for what angle creates that arc. So we're looking for the angle that has endpoints on M and K, and then the vertex outside of that arc, like on the other side of the circle from that arc. So KLM creates that arc, KJM. And because angle L is 90, we double it, there's 180. Okay? JL, which is, I have to erase some of this stuff here.
It's angle M.
JL is the short way from J to L. What angle, quiet please, what angle creates arc JL, Kylie? M does, right? It's got the endpoints on J and L, the vertex coming from point M. And if M is, what was it, 60? What's the measure of arc JL? 120. Okay. Lastly, we're looking for arc LMJ, which is all the way around here. Notice it's a major arc, so we're going the long way around. Start at L, go through M, end at J. Vince?
Yeah.
Roll. Vince, what is the measure of arc LMJ? What's the angle that creates arc LMJ?
Right here. JK.
I'm not kidding, Vince. What is the angle that creates It is angle K. Okay? We've got our vertex on the circle and those rays coming out. So we know what angle K is. We wrote it in there. It's 120 degrees. Jack, what is the measure of arc LMJ?
Whatever I'm 360 minus 120.
240.
240.
So we double the measure of it, the angle,
Oh.
which gives 240 anyway.
So
Happens work out. Not reliable, but in this case, that does happen. Work out. Okay, girls. Shh.
I did not.
Joey,
No, that's not. That's
Rowan, can you return the pencil, please?
return the pencil. I was giving it. Return the utensil.
Your homework for tomorrow.
no shot.
We don't have any time then.
On page 676. Oh, that was the same. Apparently not, because I thought I assigned you 4 and 5. No number game today. You are to do 3 through 8. 13 through 15.
That's
Alright.
18.
Oh.
And 40 through 42.
What? What? Yeah, I'm not doing this.
You heard it, folks. You're not getting that game tomorrow because Vince refuses to do work.
Come on, man.
You heard it from his mouth.
Shit.
You heard it from his mouth. That's how you have, folks.
Like it on